Hello, everybody. Welcome back. I'm gonna throw out my gum. Glad to see you guys here. So this week we're working on deployment. We'll just get into a couple announcements, but this is a pretty exciting week. This is like our last real week before we go into some extra topics. But yeah, here are some announcements. So PA4 is due tonight, 11:59. You can use slip days on that if you have some left. PA2 grades are actually all done, so I'm gonna release them right after lecture. Yeah, and then for the hack challenge ed discussion, make sure that you're all in that, and also make sure you're all assigned to teams. If you're not, just come see us afterwards. We can assign you to a random team. But if you didn't fill out the form, then you're probably not on a team right now. Yeah, and meet up with your teams, get to work. You got a couple weeks, so yeah, start early. You don't want to have to do it all at the end. Yeah, so let's get into some review of last week. So last week we went over containerization, which means packaging your code into standardized units of software. So this means that no matter what computer you have, no matter what you're running on, you should get equivalent results. And we did this through Docker. And you remember we built our code into images, which are like the blueprint. And then we use those images to run containers, which is like the product of the blueprint, like the house. And then we would push those images to Docker Hub, which is like GitHub, but for Docker images. Another quick review about servers, because we'll be using them today. So servers are a software or hardware device, like we've been using our computers as our servers, and they accept and respond to requests made by the client, and requests are made over a network. Yeah, so you can think of servers like a waiter, and you're giving them something to make, and then they'll do it and make it send it back. So they respond to requests made by the client. Some examples of a server are web servers. This is like what you're used to. They show pages, they'll run apps through your web. I don't move this out of the way, but all good. It's all good. It's all good. There's also email servers. So if you've ever used Gmail or Outlook or whatever, these are their own server that handle like emails being sent and received. In that case, the clients are the desktop apps or the web browsers. And there's also the identity server. So that manages login and security roles. So when you're logging into Student Center, it'll redirect you to CU Web Login, and that's called an identity server. So there's lots of different types of servers, but they're all essentially the same concept. You also have an IP address. So an internet server is assigned an IP address, and then the IP address will distinguish a server from the others on the network. So one that you might be familiar with is 127.0.0.1, and that's the one that basically just universally says this computer. So that's like your local host, that's this computer, right? But you don't connect to a server generally through the IP address. You connect to it with a domain name. So you might be used to like www.google.com. And that's a domain name, which gets translated into an IP address that the computer can understand. And that's done using a DNS resolver. So basically a little go through the flow here real quick. First, you're going to reach out to the DNS and you're going to say, where is google.com? Because that's what you're trying to reach. And the DNS will tell you the IP address that google.com wants to use. And then you're going to connect to google.com using that IP address. Yeah. So that's pretty much about it. Just a quick review. I think we went over this already briefly, but any questions on that before we move on? Cool. So yeah, we're going to get into deployment today. Some pretty fun stuff. And Joshua's going to go over the main lecture.
Right. So yeah, this is usually like the hardest lecture and demo like in the class because there's a lot of things that can go wrong, and it's the way we debug this is really different from how you guys have been like debugging code. So this is more the DevOps than actual software, like the software engineering portion. So yeah, so let's think about first like what our app needs. So number one, obviously it always needs to be running because we're hosting a backend, right? So the front end people will always need to have our backend running for them for the app to work. It has to be open to receiving requests. So it has to be public, right? Yeah, be publicly accessible on the web. So right now we're all hosting it locally or like in a container locally. So although like last time I showed you guys how I can, how you guys could access my backend on this network on like this Wi-Fi, it will not be accessible for like someone in a different hall or a different dorm, right? So we want it to be publicly accessible on the web. And also we want it so that the hardware is managed for us. We don't actually have a computer that we're running just for our backend. We want it to be managed for us. And we want to have it on the cloud as well, right? We don't really want to have it physically here. So yeah, we're going to be working with the cloud for that. So one important concept to learn about, which actually this wasn't here last semester. I actually added the explanation of this, like just for this semester, because I thought this was important. We'll be using virtual private cloud networks. So this is a VPC network. And essentially, second line here, it's a virtual version of a physical network. So if you guys know about like LAN, like local access network, I believe, like if you have like a LAN party or like a LAN connection between computers in like a computer lab, this is a virtual version of that kind of network. And inside a VPC, you have subnets. You can think of subnets as like regional resources. So like later on, we'll see US Central 1, Europe West 2. These are just like different regions where Google has servers, and we can actually have subnets in that area. And then inside each of those subnets, like where Google has like a data center, we can have virtual machines, VMs. These virtual machines are just like a computer running on OS where you can like host your backend. And the fifth point here you have to take note is like the routing between all these like different subnets, like because we have like a server in Asia, one in Europe, one in US. These all are like the routing is handled by Google for us, so it's much easier for us. We don't have to like deal with any of the routing or like the connection between them. And the last point is firewall rules. So firewall rules is sort of you know how like the laptop you can have like a firewall on your like single laptop. Similarly for VPC networks, you can actually configure it like what firewall rules for the entire VPC, but you can also configure them per VM. So it's possible to like um change or like edit them per VM. So I thought this was a bit hard to understand, so I made a nice like graph or like analogy here. Let me move this away. So you can imagine a VPC network as like an office building. So like every floor is a subnet or a different location, different region, right? And then for each subnet, we can have a VM, like imagine this as a computer, or we can have like multiple VMs in each subnet. So this is like multiple machines in different areas. So like four in Asia, you have like one in Europe, three in US, and stuff like that. So this is each floor is a subnet, and you have virtual machines in every subnet, right? And then for every single subnet, you can have like a security guard for each floor. Um, so like this security guard for each floor is essentially like the firewall rules, and they're not the same security guard for every floor. You can have different security guards for every floor, right? So that's my analogy of like firewall rules, because it's configurable per subnet and per VM. And then you can have the routing here. So this, I just put a telephone image here and like they're connected. So this, like you can imagine these like telephones are connecting each subnet with each other, each VM also with each other. And that's supplied by this Google truck I put here because we're going to be using Google Cloud. So hopefully this makes it a bit more clear. I actually have one more thing here. Yeah, so what I said about firewall rules is they are meant to be like configurable per VM and per subnet. However, um the point of having firewall rules for a VPC network is so they're all like centralized. So you can have like firewall rules for the entire VPC, but then they're configurable per VM. So like you can imagine as a sort of security guard course where like all the security guards are like deployed or like they all like originate in the post and then they like go to their like specific floors and like they guard their floors. So hopefully this analogy makes sense. And hopefully like to be able to connect it to the actual thing we're talking about, I have another graph here. So this is the graph from Google. So you can imagine like see different we have the different areas here, different regions, and these two like big squares. So like okay, the big squares are VPC network, right? Inside GCP, Google Cloud Platform. And then we have US West and US East. Those are two like different areas. So they have subnets, right? And in each subnet you can have multiple VMs. So that's sort of a more technical graph on VPCs, I guess. Does anyone have any questions? All right. So it's just essentially like a network. You can have multiple regions, and in each region you can have different computers. So what we'll be building today will be just we're gonna set up a VPC network, and then inside we're gonna have one subnet. We're just gonna choose like the closest one to our location right now, which is I believe like Northern Virginia or something like that. And then we're gonna have one VM. So this like shows like multiple, but we're just gonna use one for now. So yeah, let's get to it. So how do we rent a server? So we want to. Oh yeah, question.
So like, what would you have like multiple VMs for? Like, would it, could you like use that for our case? Like if it's like, you have a lot of like requests going through, or is it a completely different experience?
Yeah, so I mean, first of all, like you can have multiple subnets. Different subnets means you're in different areas. So like if you have like a user base in like Korea or like in Indonesia, for example, you would want something closer because it's definitely like faster, right? But in having multiple VMs, that would probably be if you're trying to scale horizontally. If you have an application that can scale horizontally, like I think we talked about this in one of the lectures, right?
What,
I
scaling?
forgot. Yeah, scaling. Or maybe we're talking after this. But yeah, if you want to have like if your backend just has like so many users, you want to keep growing it, you can have multiple VMs. We'll talk about load balancing after this. But essentially, like you could also have multiple apps, but you could also scale an app to a larger size. Does that answer your question? I don't know if I'm. Yeah. All right. All right. So renting a server. We want to run our application on a server in the cloud, right? So, and we'll also use what we learned. We'll containerize it. We'll push it to Docker Hub, and then in the server, we're gonna like pull from Docker Hub and then run it just like we do locally, right? So this allows the server to be managed by a cloud service. In this case, Google Cloud Platform will be using. They will handle the physical maintenance for us. We won't touch any of the hardware. But they will also provide tools to help us with security, scaling, and crashes like logging. So this is a brief overview of what we're gonna do. Um, Moving on. Yeah, these are just a bunch of different services you guys can use. We'll be using Google Cloud. There's also Microsoft Azure, Amazon Web Services, and DigitalOcean. Um, Usually, like I think on AppDev we use DigitalOcean just because they have a much more clean and user-friendly UI. But essentially, it's just a wrapper. It's the same thing. It's just a bunch of VMs, but they have a nice UI. But today we'll be using Google Cloud, but they also have like a pretty good UI. Yeah, so how do we access the server once we actually rent it, right? So the way we do it is using Secure Shell Network Protocol, SSH. And this gives us a secure way to access a computer. We can open and view resources, execute commands, and install packages and update software. Essentially, we will be given access to the terminal or like the command line of that virtual machine. So it will look like something like this. So this is this once we SSH, which we'll show you later. I mean, here we're actually SSHing into Eatery's backend. So you can see like we provide them a PEM file. A PEM file is just like a bunch of like secrets, I believe, like access code or something like that. Yeah. I'm not exactly sure, but like we can access into this link, which is where our backend is, and then it'll actually have us connected to the terminal, so we can actually run commands inside our virtual machine. You don't have to worry about this like text. This is just like what they print when we access it for the first time. But yeah, we'll show this. We'll see this later. All right, security. So for security, you have to provide username and password credentials. Over here later, when you're trying to SSH into your own server, you will have to do it. You actually have to authenticate before you actually get access, because obviously you don't want any random person being able to like gain access to your backend, right? So you will see how we need to have credentials later on. Public and private key authentication and encrypted string that is more secure than long password. I believe this is how you SSH, right? It's just like ultra secure, just so no one has like access to your virtual machine. Because I mean, you're renting it. You don't want anyone else to access it. Let me just cross over that. Yeah, so I mean, the basic command is just SSH and then user@server.com. So this is the username that you have on the server, and then this is the URL for your server. And then once you run this command, they'll actually prompt you with to ask for credentials, like a service key and request to connect. And if you haven't connected yet, if it's the first time you're connecting to that server, you have to add to known hosts. So it'll just like remember that this virtual like you have access to this virtual machine. And yeah, and if it's successful, open the command prompt. Yeah, I'm just glossing over this really fast because I want to get to the demo. But we'll see more of this like later on. Yep. So now we're going to be deploying with Docker and Google Cloud. That'll be our tech stack for deployment. Um, so Google Cloud is a cloud service. It allows you to deploy Docker images easily. Um, and you can build, push, and release images to the web. So it's essentially just Google Cloud has like almost an infinite number of services. But we'll be using their service to rent a virtual machine. But from that virtual machine, like how we did locally, we can pull image Docker images and we can run them. So I think this is quite clear. I don't know what else to add. Uh, yeah, and this is the part that we're actually not going to do, but we're going to teach you the theory of. So how do we optimize, right? So one topic or theme you will find in like real DevOps that we're not going to be going into, we're just going to teach you theory, is clustering. So an overview of clustering is you have a group of servers connected to behave as one system. Because when your app or backend is big enough, so that like instead of having one big computer, you can have like multiple smaller computers. You want to use clustering because again, like each server is optimized for a particular purpose. Like you can have one as the like the that runs the app.py and one that actually stores the data in the database. And it just allows for a better performing system. So I can give you an example on app dev. Usually what we do is we have our backend, which is usually our app.py, right? App.py file is how we like organize the logic, how we package data before sending to our users, right? We have the app.py on one VM, one virtual machine. And then what we have is we have a cluster to hold our databases. So the actual rows and like the actual tables will be in another separate cluster. And we can actually connect between those two servers to grab data, pass it to the app.py, like the other server, which then works on it before sending back to the client. So clustering is this, yeah, you have a question? Yes, a virtual machine is it's a server. You can think of it just as like a computer. Like imagine you have like a Mac in the cloud, like or you have a Windows laptop in the cloud. They're just machines, they're just computers. And we just call them a server because in this case we're not using it as like a client, we're using them as a server. Um, but yeah, we can have like multiple servers. Usually we separate app.py and db.py. So one holds the data, one actually works with the data before sending back to the user. So yep. Yeah, this is how it looks like. So right now what we're doing, we're actually running like all our apps. We're running like the CMS, Venmo, Reddit. We're running it locally, right? So it's just one laptop, for example, your own laptop. It will host the web application that you're running with Flask, right? It'll have all the file storage. In this case, we're not really storing any files, but you also have the database. So this is all the rows of data. All of that is in one server. So like on your laptop right now, you have both the web application and you have the database, right? In real production, usually what you would have is you have multiple servers like this, which is what I was talking about for AppDev's case. We'd have like one server just for the web application and for the logic. Maybe like a bucket here or like another server for file storage. Like if you want to store profile images or like just other files, maybe PDFs or something, we can have another server for that. And then we can have another server for just for the database. So like the user rows and like the tables and everything like that. And then like what these like we'll have to make them connected, right? We have to make sure server one can communicate with server three and server two can communicate with the other ones as well. So it does get a bit complicated, but this is the more efficient way to do it because you're abstracting out again. You're like data stays here and the web application stays here. Does that make sense? Because right now, like everything looks like this on your computer. So in real production, you could have like multiple servers. Right. So the benefits of this, backups and crash handling. Obviously, if one server goes down, hopefully your other servers don't go down. Data resiliency, application resiliency. Obviously, like for app dev, for the apps we build, we don't want them to go down at any time. Like for what if like Eatery goes down and you don't have any of the dining hall data? That would be like catastrophic. So we always have like backups, and we also have clusters to make sure that like it doesn't go down. But
I think it went down today for like a couple minutes, so sorry about that. We got it back up though.
yeah, it's also good for system management, scalability, and load balancing. So we actually go into load balancing after this. So yeah, the load balancer. This is if you go on to a larger scale, you need a load balancer. So what a load balancer does is it's essentially like And this is your input point or like the gateway to your backend will have to go through the load balancer first. And the load balancer will like on a high level, it will essentially like spread out the work between the different servers, web app 1, web app 2, and web app 3. And this ensure that none of the single servers, like one of these servers will like get overloaded with like requests. So this works when you're trying to scale up an app to a really big size. You would want a load balancer to determine which server you're like requesting from. Yeah, but we're not actually gonna implement that actually. This is just for theory, and this is cool to know, I guess. Moving on. Yeah, so like I said, the network traffic will first go through the load balancer and it will direct it to the different servers. Yep, like that.
So if one of them's like very busy for some reason, it'll direct it to another one. It'll try and keep it up very even. It'll manage it all for you.
Yep. Google Cloud also has load balancer. I actually played around with it before. It's kind of complicated. It's like a lot of stuff to set up, but it is a thing. So yeah. So in this case, it's also easy to scale because if you want to have like more, your app just gets really popular or something like how like BeReal exploded back in a couple of years ago, you can just add more servers and you have the load balancer like direct all the flows to different like servers. So yeah, it's very handy. All right, so let's go into the demo. How much time do I have? Around like 25 minutes? Shall we?
All right.
You want to do the first part?
Yeah, we might try and like crank out the full demo today if we can, because if we could get it done today, it would be kind of legendary. Our semester, when we took the course, the people were just like debugging the whole demo. So we're gonna try and do it. But yeah, let's get started. So the first thing we have to do is go to our Huh? Oh yeah. So we got you guys some Google Cloud credit, so you don't have to pay for anything.
$50.
Yeah, $50 each, pretty good. And we made an ed post for you to redeem that. You just fill out a form and it'll send you an email. It's pretty simple, and then you just enter in your code and it'll give you free credit. Uh, yeah, I think that's pretty much. Yeah, you have to use your Cornell account and you only get one like redemption per account. But yeah. What'd you say?
Create a project. Yeah.
Oh yeah. So we want to go to this Google Cloud dashboard. If you go to the demo here today, you can just click this Google Cloud link. So it's Lecture 6 demo, go to Google Cloud, and then click go to My Console, and that'll bring you here. So the first thing we're going to do is just make a new project. So this is just like an app, I guess you could think of it as just any like a project you're working on. So we'll make a new project here. And we're just going to name it like demo 6, and we'll name it, yeah, we'll just name it demo 6. I think it's fun. And then organization will be cornell.edu and location will be cornell.edu. This should be set up for you as long as you're on your Cornell account. Don't need to worry too much about that. Cool. And then once you create it, you have to make sure you actually switch to it because it's creating right now. So we'll wait for that to create and then we'll switch to it. So now we're in demo 6. Perfect. The first thing we have to do, we're eventually going to want to create a VM, but we have to make the VPC network first, as Josh mentioned earlier. So that'll manage our VMs, or in this case, singular VM. So we click on VPC network there, and it's going to give us this error, data could not be loaded. It's all good. We click continue. It should bring us to this API. So we have to enable this API from Google for it to work. So this might take a second, but
Yeah.
they have all these different services you can activate for your projects. So there's like this compute engine here, which lets you do the VPC networks. There's like YouTube API to give your project access to the YouTube API. All sorts of different things you can do. We'll just wait for this to activate, and then we'll create our VPC network. There's going to be a lot of just like following along and copying what I do for this section of it. But yeah, it's not too difficult. You just got to kind of follow along. So we're going to create a VPC network right here. And we're going to name this demo 6 network. Cool. Name is good. We don't really need a description. There's going to be a lot of stuff that like I don't really know what it is. You don't really have to know what it is, but you can look it up if you want to know. But I'll tell you about the important stuff. So this you don't need to worry about. Don't need to worry about that. For the subnet, so that's what he was talking about, like the different regions. We're just going to set it so it's automatic, so they'll handle it for us. That's perfect. anything else we need. These are the firewall rules he was talking about. So this will tell like our VMs which specific firewall rules we want. So the only one we want for this is allow SSH. So this is going to allow us to SSH into it. Um, oh yeah, we just also want to make sure that I think it's handled for us, but if you're on custom, you'll have to disable your yeah, it's fine. Just do automatic and you're good. So you want to allow SSH here, and everything else should be fine. We're just gonna create it. Gotta move my face. Might take a second to create. Yeah, pretty quick. So we're creating our network here, our VPC network. Then once we have that up and running, we're just gonna create our VM. Yeah, so it's a lot of just like learning the UI for this. But once you kind of understand the core concepts, your VPCs, your VMs, all your Docker containers, your what SSHing is, etc., you can use any of the cloud platforms really. So like AWS, Microsoft, Google Cloud. Cool. Our network got created. So we're gonna head back to our main. Yeah, you can click here and then click Compute Engine. That works. And then we're gonna try and create a VM. So we'll go to VM instances. Cool. Once you're here, you can just create instance of a VM. Looks good. We'll just rename this one. So I'll name this demo 6 VM. Doesn't really matter, but that's good. I think the closest one to us here is North Virginia. So we'll do that. It doesn't really matter though. It'll be pretty minimal difference. And then zone is all right as is. You can also switch this. There's lots of customization options about your VM. So you can set lots of different memories, CPU platforms. vCPUs means like how many virtual CPUs is what that means. It's basically just your processing power. You don't really need too much here, and we don't need to like optimize it for memory or storage, but you definitely can if you want to do that for your own projects or your own hack challenges even. And then we're just going to set a preset machine here. You can do medium, micro, small. There's lots of different options, but we're just going to do small here. Doesn't matter too much. We don't need too much memory, but you can see like the specs here. The other thing you can notice is that your cost is going to change depending on how much processing power you need. So small is going to be less than large. Pretty self-explanatory. Yeah, so I think we're set for this page. We just got to go to OS and storage. And we're going to go through these. So the first thing, we're just going to change our operating system to Ubuntu. And we just do this because it's very commonly used in industry. App dev does use this, or at least used to use this. It's pretty standard. It loads quickly on Windows. It's easy on Windows. So yeah, and then the rest should be all set. We're just going to select that. So we'll be Ubuntu. I don't think we need anything in data protection. Then for networking, these are some of our firewall options specifically for the VM, like you mentioned. So we're going to allow HTTP traffic on this one. And the reason why that's not checked by default is because HTTP is the same as HTTPS, like you're used to using, but it doesn't have as many secure, it's not as secure. So it's it's not recommended to use it like for a production app. It's the thing that like when you go onto a new website and it says your connection is not secure, that's because you're using HTTP and not HTTPS. But for our use, we're going to allow HTTP because it's an extra step to make it HTTPS. Um, and yeah, we can show you how to do that if you want at some point, but for now we're going to allow HTTP. We're also going to look at this network interface. This should automatically be created. And if you look at it, it should automatically select that network that we created before. So this should all be set as long as it looks like this.
If it doesn't, then you might have to like click on the drop down and just like
Mhm.
select the one you created now. So like in this case, we created the VPC. It's named Demo 6 Network. So just make sure you select the one you made.
Mhm.
Yeah.
Cool. That's about it. I don't think we need anything in here. Security, we don't need anything. Advanced, I don't think we need anything. Did I miss anything?
It's good. I think you're good.
All right, so we'll try and create it.
Speed running VMs.
Yeah.
What's this?
Yeah. And then Josh is just going to start and see how far he can get in deploying today. And if we run into any errors, we'll just do the Kahoot and leave and fix it for next time.
So,
But
all right. So now our VM is like being created. It'll take a while, but so while we're doing that, let's actually build our image, push it to Docker Hub, so we can when we SSH into our server, we can actually pull it, right? So we'll go to this one, right? Laptop. Wait, this one
that's the terminal, and that's the
right here.
yeah.
Oh, it's tiny.
Yes.
Right. So we're already inside the folder demo5. So let me just control L. Let me just see what's in here. So yeah, we have our Docker file. We have the db app.py. We have our old Docker Compose from last time. We have the requirements and we have the vend, right? So the first thing we want to do is, assuming all of this was set from your previous assignments, we want to build it. So usually what we do is we just do Docker build and we write the, I'll just write it out for in this case. We want to have the tag, we want to name it something. So that be, what are we naming it? Like demo 6.
Yeah,
is that free?
6, yeah.
Demo 6. And then we have so this is the username, we have the repository name, and then we have the tag. So let's say v1.0. This is usually what we do. But in this case, because our virtual machine we selected Ubuntu, right? It was a Linux operating system. We want to actually build this for that platform. So we can't just build it like this. If we build it like this, it will build it using the ARM architecture, which is what the Mac uses. So when we run it or we pull it and run it in our server, it won't work. So we have to actually set the platform here. So I'm going to do -- platform. Let's make this bigger. -- platform. And then here I'm gonna set to equals Linux / AMD 64. And that should be good. Yeah, and the dot. So you add the platform flag, and then here just make sure you're building everything in the directory. So let's try run this. Is your Docker open actually? It is, right?
I think it is.
Run this. Yep. So now it's building. Yeah, build that pretty fast because we already built it. This is on a different platform. So now let's go for images to check. Yeah, there are many images, but it should be demo 6 right here. Wait, 33 minutes ago? Why does it say 33 minutes ago? But did you already create one with demo 6 name?
I don't think so. Perhaps though. I don't think I did.
Huh. Why does it say 33 minutes ago? Oh well, we already have it. We have to I named it correctly, right? Demo 6 V
I think it
1.0.
should be good.
All right, it might be like bugging out or something, but we have the image here. So now we want to push it to Docker Hub because this is an image on locally, right? So let me clear again. So to push it, we're just gonna do Docker push, and we're gonna specify which image. So sky battery slash what was it again? Demo 6, and the tag was v 1.0. Yeah, so we want to push everything in this directory. So don't forget the dot again. Wait, do we need the dot? We do, right?
I think so. That is what was true.
Oh, wait, no, we don't need. What am I doing? We don't need the dot. Yeah, because the dot was just for building. Sorry. So yeah, we just push this one to Docker Hub. So if we go to, can I open your Docker Hub?
Yeah,
It's fine, right? Go to Docker Hub right here, and I search Sky's name. There should be demo 6 right there. So updated a few seconds ago. So you can see now it's online in Docker Hub. Our image is there. Tags this view 1.0. So now let's go back, or our server is actually already up now and it has the IP here, but we'll go into that later. Okay, let's go back. So we pushed it to Docker Hub, right? So now we have to, we have it on Docker Hub. We're done with everything locally. Our image is ready in Docker Hub. So now what we have to do is we have to start working in our server. So the first thing we want to do is actually SSH into the server. So if you look at your newly created virtual machine here, you can see on the right, there's SSH. So you can just click that. And it'll bring up this, like, this is where it's trying to authenticate you. Yeah, so he's transferring the SSH keys to the VM. And then let me just click authorize here. So this is Google, so it uses your Google account. But yeah, there you go. So now we're already in our virtual machine. You can see this is the same like thing we saw in the slides. This is like literally our virtual machine. This is a computer we rented from Google. So let me just Control L and like just clear everything. We can do like LS to see what's there. There's literally nothing there right now. And yeah, we can play around with this computer essentially. We rented this. So the first thing we want to do, Actually, let me just outline what we're going to do. First of all, we want to actually download Docker because our virtual machine is like clean. It has nothing. We're going to download Docker. And then we're going to separately, we're going to download Docker Compose because it's not included with Docker. And then we're going to pull from Docker, and then we're going to run our app using Docker Compose. So first, let's go and download Docker. So we go to our like demo page here. We actually have all the links here. It's really handy. So the Docker installation guide is here, and the Docker Compose is right here, the installation guide. Let's open that up. Let me move that here. And essentially what we're going to be doing is just like copying these commands. So first we update our, where is the SSH? Is it like hidden behind? Oh, it is. Let me just move this. Maybe this works. Yeah, so first we'll copy this. It's updating all our packages, making sure it's updated. And the next one is this one. We want to install a prerequisite packages. Oh, I didn't copy that properly. Copy this, paste it, run that, right? And here you gotta just click like enter Y to continue. And then here you add the GPG key for the official Docker repository to your system. Don't ask me what all of that means. This is just on a high level, this is just downloading Docker. And then add Docker repository to the apt sources. That. Yep. Let it run. All right. Let me just Control L just to make sure it's clean. And then here you want to, again, you want to update all the packages because we just added stuff. And then here we want to check for, you want to look at this output. So you see Docker CE is installed, and you can see the version table here. Yeah, should look like this on the website. And then finally you want to install Docker itself. So you want to copy this, install that, and enter Y to continue. It's downloading. Yeah, we just wait.
Yeah.
See.
We don't have too much time, but if we finish today, we can just make class Wednesday optional office hours. So how many people would want us to try and finish? Maybe we go like 3 to 5 minutes over right now, and then you'd have
All right.
Okay, yeah, we'll do that.
Also, the hack challenge starts today, right? I feel like you guys can start. Yeah, you guys can start work on it. If you guys like on Wednesday, if you want to come and we can help you like brainstorm, we can help you think of how to implement stuff. But yeah, so this Docker is done. So we can actually check if Docker is running by running this. And you can see here it's active running. And you can just Control C to get out of this. Yeah, so now we have Docker installed. Step 2 is to install Docker Compose. So let me go back here. Let's click the Docker Compose installation. This one's much faster. You just copy this one. It's just curling from this URL. Then we set the permissions like that. And then we just check the version to make sure we download it. And there you go. We have Docker Compose version 1.29.2. So now we have Docker and we have Docker Compose, right? So let me just Control L to remove that. Let's go back to our Actually, we don't need this. Okay. So now we have everything installed. We already have our image on Docker Hub. So what we want to do here is we want to pull from Docker Hub, pull our image. And remember inside your SSH or your terminal, you want to follow every command with sudo first because it just gives you like administrative access. If I just run like docker pull, it won't work because it's not using administrative access. So just remember to use sudo behind everything. So sudo docker pull, and it's sky/slattery/demo6, and the tag was v1.0. Yep, looks good.
Looks good.
Yep, let's enter that. So now it's pulling from Docker Hub into our virtual machine. We just wait for that to complete. And the next step is actually to like manually transfer or manually copy our Docker Compose file. So we want to run everything with Docker Compose, right? Remember how last time Docker Compose is not part of the image you like compressed. So Docker Compose is a file you have in your directory to run images. So right now we don't have Docker Compose in here. We have to actually take it from the one we made last time. So the pull is complete. we can do Docker. Okay, let me just give you an example. If I don't use sudo, Docker images. See, it says permission denied while trying to connect. The solution is just use sudo. So sudo Docker images. And see, we have one image here. The size is pretty big. It's nearly one gigabyte, right? 933 megabytes.
No,
Oh,
almost 100
I'm
megabytes. I think 1,000 megabytes.
Oh, 1,000. Yeah, right. Nearly 1 gig. But yeah,
Oh, is it 933?
yeah,
Oh,
it's
then
pretty
yeah.
big.
Then
So
yeah.
this is a repository from this is a tag, and this is the image ID. So we have the image there. Now we have to get the Docker compose file to run it. So we go back to not this one, VS Code. So we made this Docker compose file last time, right? So what this does is, remember, it uses this version. Although this is actually deprecated, this was actually deprecated using the version stuff. That's why we had an error last time. But we have the services, and then we're gonna run demo, and the image we're gonna run in this case, I'm gonna change it. So it's demo 6, and then v 1.0. I'm just changing it here so I can copy paste it easily. And then we have ports. And ports here, remember, the first one is the host port. And the second one is the port where your web app is running. So like, remember how in your code you always wrote 5,000? This is the one, but this is the port. This is the host port that you're going to be running it on. So remember, your virtual machine is a machine on Google Cloud, and inside it, we're going to run a container, right? So inside the virtual machine, we're going to run the container on port. In this case, let me just use port 80. We're going to run the container on port 80, but inside the container, we're going to run our app in port 5,000. Does that make sense? I'm kind of speed running this, but yeah, let's see if this works. And actually, let's not do the env file for this demo. We just have it like this. Let me just copy this and then go here. That's clear. Here we're gonna create a new file. We're gonna create the Docker compose file. So I'm just gonna. I don't actually need that here at this point. So I'm just gonna use Vim. So Vim docker-compose.yml. This will just create a file, an empty file, and open it in Vim. So this is Vim. Welcome to Vim. It's just like an in-terminal editor. You can click I to enter insert mode. This is where you can actually edit. So if I try and type here, it won't work. Like it will work. It actually just switched to insert mode because I pressed I. But you have to first press I to get into insert mode, and then in here you can just paste it, right? You can paste your Docker compose file, and then to get out, you have to do colon. Wait, first you have to escape the escape insert mode by pressing escape like that. So now I'm not insert mode. And then I do colon, like you can see the colon typing here. W, what W will do is it will save my file. And I do Q. What Q will do is it will quit Vim. So if I just do W right now, it will just save but keep me in Vim. So I can just W. It just keeps me here and doesn't exit. And if I want to get out, I can do colon Q and that will quit. But the easy way to do it is obviously to colon WQ, save and exit. So I'm just going to do Q here.
People who are not here right now are definitely getting stuck in that terminal.
They're getting cooked for the hack challenge. All right, so now let's ls. That's just to see if we have it. Yeah, we have the Docker compose file here, and let's see what's inside. So I'm gonna print it out, and we have all this here, right? So now the last step you got to do, you have the Docker compose. Last step you have to do is the sudo docker compose up, and let's run it in detached mode. Remember with the -d. Let's see if this works. All right, so now it created it because it's in detached mode. Let's see if it's actually running by running sudo docker ps to list all the running containers. You can see it's right here. Let's see if it actually, let's look at the log. So we copy the container ID, we go sudo docker logs, paste the container ID, and we can see the output is actually like it's running. Wait, hold on, not yet. So now it's running on our virtual machine. Let's go to our Google Chrome. Let me just make this bigger. Oh crap, my bad. Let's just keep it like this. We go to VM instances, right? This is terrible. Okay. So now what we did was SSH just now, right? But this is actually the external IP, the public link that we can actually like use to see our running instance. So if I just click this, there we go. All right. Yeah, so we got hello world. That was like that was the first thing we have in our VS Code right here. So if you go app.py, down here we had where is hello world? I forgot what hello world was. Right here. So that's what we have here, right? So technically if I do like /task right now, it should work. I don't know if it's gonna work. Because I don't know if the previous file was working, but if I do /task like this, Oh, there we go. It worked. So this is our backend, like fully online. You guys right now, you can actually go to our backend. You can enter this in 3448101169/task. You can put this into Postman and add your own task if you want. It's completely online for like anyone in the world basically to access. And this is like that's the deployment. So we've deployed on Google Cloud. Hooray.
Let's go.
Hey, that's
One
crazy.
small step for Joshua. I haven't thought that one through, but it's in the it's in the.
Okay.
All right, let's
And
do
then
Kahoot. Oh,
yeah, let's do code. One more thing, if you want to close it because we ran discharge mode, remember last you can actually just docker compose down and this will like shut it down. I don't know if you guys are adding tasks, maybe we'll shut it down afterwards,
oh no, I don't think we should see what tags they're adding, bro.
but yeah, you can add tasks in Postman. Let's do the Kahoot now.